So what we have for question 4 is, what is metallic bonding? Okay, so in short, metallic bonding is when two metals are bonded together. So there are common examples of metallic bonding. So like gold, for example. Okay, it isn't actually an element, but to get that whole gold bar, that is, oops, okay, to get this whole gold bar, there's metallic bonding that happens, pure gold. Okay, and when you think of actually steel beams and stuff, that those are alloys, okay, formed through metallic bonding. So in a sense, it's just I believe it's like iron and copper or something like that. There are some metals that form together for alloys, but point being is that you see these ones here, the alkali and alkaline metals, those ones are metals that I'm referring to, but also everything that's possible, at least in the natural world, but everything here that you see as transition metals, those also count as metals. So if you see gold bond with gold, they have a very strange way of writing it, but this is a metallic bond. Okay, if I gave you something like lithium and calcium, so Li2Ca, I think that's even what's in batteries or something, but this also is a metallic bond. As long as you see two, or the constituents are all metals, that is a metallic bond. So that's really all we have there for metallic bonding, as long as you recognize that after group 13 and on, those are no longer metals. Those are more so non-metals than anything, skirting the line, because as you know, mercury is what we use in thermometers, and that one is liquid in room temperature. It's very strange, but like that's when we might transition metals. They are in a sense weird metals. So just make sure that you notice your periodic table and you see if they're specifically referring to two metals bonding. There is also a way to be able to say it's a metallic bond through the electronegativity, but that one is not so discussed just because it's hard to tell when it's actually a non-covalent bond versus a metallic bond. So I wouldn't use that one as a reference. I just always notice if the elements they're talking about are metal or non-metal. Make sure that all the ones mentioned are metal, and you can safely say that it's a metallic bond. Okay, so let's see what they said here. So give me a second as I grab a charger. Metallic bonding, some metals, and this is kind of how they look like here in this picture. Yeah. And that's actually good to know. So metallic bonds, as they say here, actually high melting point, they're usually the hardest types of bonds to break, even stronger than ionic, even stronger than, I think ionic is the strongest one actually, but yeah, even stronger than those bonds. Metallic bonds are quite difficult to break, hence how they have high melting points, which is why you need like really high temperatures to melt things like gold, steel, and all that stuff. So yeah, and they do mention more things like how they can even be conductive and everything. So metallic bonds overall quite cool, quite different from what usually is talked about. Most courses of chemistry focus on everything else really, covalent bonds and ionic bonds. So metallic bonds is the odd one out, and now we know how to be able to identify them. Okay. All right, let's move on to question 5.